Okay, I'll go ahead and start knowing that there are other people that are coming.
You two, and that's complete, right?
Yes, that takes. Yes. Util takes me to all the talk slides, and then you want what Raku for beginners. Okay, I know other people are coming, but we're starting. So, the preface, quick, with introductions. Supposed to be playing the music Threshold from Scott Pilgrim versus the World because we're in Toronto. In the schedule, if you use the default view instead of the grid view, you may not realize that, I can't show it on here. Hang on. There it is. There. This class is more than an hour. You're welcome to, come and go, but I want you to be aware that you are missing these talks potentially if you're in here. So come and go as you please, but I don't want you to be caught unawares as has happened sometimes in the past. The language formerly known as Perl 6 is Raku. You will often hear me say Raku instead. That doesn't mean you've been saying it wrong. Technically, any of them are right. It's just Raku is slightly more right. I'm Bruce Gray. You'll find me as Util online. I've been working with Raku for over 20 years. We would not have this free class today without Jonathan Worthington's original version of the class and Patrick Nishaw's improvements to the slides. I've made many changes myself, but this class is really based on their work. So thank you to Jonathan and Patrick. This is to teach programming in Raku, not to teach programming, in Raku. You can use Raku as a first language, but that's not what this class is. It will only work in this class if you already know how to program in something. And that's, more for the people watching at home than the folks here. But really, if you can program already in any other language, then you're in good shape for this. We have about 3.5 hours minus breaks. We cannot come close to covering all of Raku in that time. So we'll be skipping a lot of cool stuff. The stuff that's unlikely to be useful to a beginner. That still leaves a lot of cool stuff. Welcome. Our focus is going to be the core syntax, the inescapable concepts like the type system and lazy lists, and a bit of how to think in the Raku way. Every so often, we're going to have try it and see slides. Those are chances for you to try things out yourself in Raku. They're going to start out simply as one-liners in the REPL. Later, we can move on to writing scripts. Hopefully, you read the session abstract and already have Rakudo loaded on your machine. And we encourage pairing, especially if there's some of you who really know already and those of you who really don't. Pair programming is very effective in a classroom setting. And if you don't have the Rakudo compiler installed, these are some alternatives. For small things, you can just go to Glot and run it on the web. If you have Docker, then the Docker run, we've got Windows and Unix variants there. Those work very well too. And again, that's why you need the slides, is so you can not have to memorize that command line. Finally, I want everybody to be able to hear me easily. If I ever fade in volume, somebody signal me till I get the signal. I'm not going to try and sell you on how awesome a language this is. I think that'll come through. But we're just going to start out with values. Not even variables yet, just values. Integers, whole numbers, positive and negative. That's a type of a value. Rationals. What you're reading as 0.25, well, Raku reads that as 25 over 100, reduces it to 1 over 4, and stores it as numerator 1, denominator 4. So a 2-compartment storage. And don't worry, they did figure out how to do that efficiently. It wasn't thought possible for the longest time. They figured it out. 5.05 is going to be stored as 101 over 20. You won't see it that way unless you ask to see under the covers. It'll print out as 5.05. But behind the scenes, the rationals just silently do more accurate math for you. But we do have floating point numbers. We get to them via scientific notation. In Python and in C, there's a trick that if you want an integer to be a floating point number, you put a .0 after it. So like 5.0 is different than 5. 5 is an integer. 5.0 is a floating point. That's not true in Raku. 5.0 is just 5. So if you want to force it to be floating point, just put E0 at the end, the old scientific notation. Tells you the E tells you how many decimal points you're sliding. So E0 is you're not sliding at all, but make it floating point. You can discover what type of value is by using .what. We have all uppercase method names and things generally in Raku as an alert. Something funny's going on. Maybe this is something you shouldn't be doing. Maybe this is something there's a better way to do. In this case, if we're just doing inspection, our curiosity, perfectly fine. But if you're doing something like .what and then comparing that to int, then that's probably not what you should do. You should smart match to int, for example, to find out if something's an integer. So these are the official type names: int, rat, and num for integer, rational, and floating point. Oh, and there is Q&A at the end, but it's very open. Let me know if you have any questions as we go. So we have the usual set of numeric operations available, and they're defined on all the numeric types we've seen so far. Those last two are modulus, like the remainder after division, and exponentiation, raising something to a power. So, your turn. Using the Raku REPL or GLOT or whatever, try to work out answers to the following. I'll give you a few minutes. How big can integers get? The easiest way is raise something to a really high power. What type do you get when you divide two integers? And what happens if you ask, is 1/10 plus 2/10 the same thing as 3/10? I'll give you 2 minutes for that. And I'll drink water. Pardon? I'm a little hard of hearing. Numeric overflow isn't. Numeric overflow is not an integer. Tell me what you just did. All right. That about right? About comfortable? Everybody see it? Okay, I'll start with I actually can't see on here while I'm typing over there. So that's child's play, right? All right, what about 2 to the 1,000th power? It's a big number. How many characters is that? 302. Okay, so you're saying
27 volumes, the power of 27 volumes.
well, what if it's just that many to that many first? And I'll say cars because we don't actually, if it overflows the screen, we can't tell how big it is. I don't regularly have people so enthusiastically challenge the boundaries.
I get to drive up, but I do 100 to the power of 10 billion.
Numeric overflow on 100 to the power of 10 billion. Oh, okay. You can do it to the power of 1 billion, but 10 billion, that's just unreasonable. Okay, so the number of protons in the universe, I don't know if it's 2 to the power of 42. It's probably something involved with 42 because, 42. But, okay, I'm happy to know this. Maybe I'll make a note for next year to put a limit on it. We did find the edge, an edge. Went off the edge. Way off the edge. Okay, so I'll point out Perl can do this too. The type is called big int, but you have to deliberately use big int. And big int is just built in Raku, but nothing is without limits, and computation does take time. And I didn't even think about if it can do that, well, how long will it take to figure it out? We'll come back to that. Did anybody do the division? What type do you get when you divide two integers? You do get a rat. And, all right, what I'm going to do here is, yes, it's going to work. Oh, you smell a rat. The operation technically known as smell. Okay, so sure, like 9/4. That's a rat. We could guess that. That's reasonable. But I think there are two reasonable answers to this. Right? 8/4 is also a rat. Why wouldn't it be an integer? It is a whole number. It's 2. Well, as I understand it, the concept behind it is that the return value of operations should be more comprehensible based on type and not based on the randomness of the value. If I say $A/$B, and I know that $A and $B are both integers, I should know what the resultant type is. It shouldn't have to rely on what the values in those were. So it's consistency in that way. We do have a way, if you want the opposite behavior, you can ask it to reduce it to the smallest type that it can. That actually does not come up very much. But you can do it if you need it to work the way I thought it ought to work. How about 0.1 plus 0.2 equals 0.3? Anybody try that? Anybody want to guess? In any language. Okay. Let's delve into that one. Oh, let's start my presentation. When you wait, say yes. Yes, because you. Okay, so the narrowing that I spoke of, you've just found that it does not extend to the nums. And that the thing we're about to cover on the 10th, I'm not going to say narrowing of a num always results in another num. I will say you shouldn't rely on it for exactly the reasons we're about to go into. I hadn't thought about that, but I don't know quite how to handle those kinds of conversations when we're filming for posterity. I want to invite it, but it doesn't get on camera. I'll briefly recount that narrow brings you to the narrowest type that can represent that value. And that's not necessarily divisive between nums and ints. But what I think you hit with your other experiment is that something may look exact in a num, even rounding when it prints it, and it's not exact, so it can't narrow to the integer or to a rational. Okay. The cage match. Yes. I don't want to ask the question, is this equal or is it not equal? Because different languages present true and false differently. So let's ask it a little differently. What do we get if we subtract 0.1, 1/10 and 2/10 added together from 3/10? Mathematically, like just on scratch paper, that's always zero. It's always exactly zero, not close to zero. It's always exactly zero. So what is it in Python? Well, it's not zero, which is why there's a whole paper on everything that a computer scientist needs to know about floating point, because this is a source of bugs. If you were to ask, are these equal in Python? No, they're not equal, because Python does it like about every other language under the sun. This is a bug in almost every language. It's a tiny number, so that e -17 means 0, point, and then 16 zeros, 555. It's really small, as small as you can get, but it's not zero, and we need true zero for equality. Well, how about Perl? We love Perl. Same problem in Perl, same number in Perl. None of those three numbers, 0.1, 0.2, or 0.3, have an exact representation in floating point. They're all slightly. So if you do math with them, the math result is all slightly. Raku gets it right because 0.3 is not floating point. It's a rat. It's 3/10. So 3/10 minus 1/10 plus 2/10 is going to exactly be zero. No need for approximations. If we force Raku to use floating point, it gives you the exact same number. But if you don't force it to use floating point, which you shouldn't, then a whole class of business problems and programming worries just vanish. Ovid did a whole talk on just that, just the impact of that, because of this excellent design. Questions? Okay, I mentioned the modulus operator, which is provided by most languages, the remainder. But commonly, you're not using it because you care what the remainder is. You don't actually see it very much to say, oh, the remainder is 2. What you want to know is A evenly divisible by B or not? And when you use modulus to ask that question, the answer is backwards. 6 mod 3 is 0, which is a false value. So it's a common bug. Like if you want to do something every 5th time, you end up doing it 4 of the 5 times and not the one that you wanted. You have to remember to do that in order to use modulus correctly for that most common use case. Wrap it in parens, compare it to 0. Raku adds the divisibility operator, returns true or false. Mod returns a number, divisibility, true or false. In the right order, easier to comprehend, less buggy, and more efficient. There's a lot of stuff in Raku's design that I'm just a complete fanboy about. Similarly, since you often do division and then throw away the remainder, which you'll see as people doing the math and then int or floor or something like that, we have a div operator. Both operands have to be integers, and it will always return an integer. If that's what you were going to do, you were going to round it off anyway. This is more efficient and clearer to the maintenance programmer reading it, which is probably you 6 months later. And note that that's returning an integer. So if it's 8div2, where we were doing 8/2 before, 8div2 is an integer without having to narrow or anything. So when you expect it to be perfectly divisible, this does what you want in giving you an integer. Raku provides all the numeric routines that I hope you would hope for. Of note is round. Read the docs. I'm not going to go into it unless we have bonus time. It does a lot more than round does in any other language I've seen. It's brilliantly designed. We've got all the trig functions, including the hyperbolics. That last row, cis through conj, are all for complex numbers. We have built-in complex numbers now. But you do have to create them. I think you don't automatically get one by taking the square root of -1. You just put I after something. Strings in source code have to be quoted in some way. Perl, we had bare words where, like for a hash key, you could just put curly braces and a bare word in there, and it would act like it was a string. We don't have bare words anywhere in Raku. If you ever looked at the Perl source code, it's just awful how it has to handle bare words. The simplest quoting constructs are single quotes and double quotes. The double quotes have much richer abilities. Single quotes do less, and therefore they're more appropriate for simple strings. For example, double quotes process / control characters like new line and tab. If I put \t in a single quoted string, I get \t. But it's actually a tab character in a double quote. We'll see more double superpowers later. Our concatenation operator is the tilde. It was the dot in Perl. It's the tilde now because we needed the dot for something more important. Larry says you should think of it like you're stitching together two strings, right? That's how you remember it. We'll also see it later as a string type coercion. So let's try it again. What happens if you forget the tilde and try to use the dot to concatenate two strings? And what happens if you completely forget to put any operator between the two strings? 2 minutes, maybe a little less. That one's easier. It's unlikely to hang anybody's computer. I think those of you who are trying for answers have achieved your answers. So volunteer on the first one. A helpful message saying you should have used tilde. Well, yes, we are sorry. We want to do what you want. We just can't. So that's like that, right? Unsupported use of dot to concatenate strings. In Raku, please use tilde. So it knows that this is a common problem, common bug. People coming from Perl, they want to use the dot. And this is an example of one of my favorite things about Raku is the error messages. We have fantastic error messages. It's a fallout of the new parsing method, which is unfortunately slower than other languages, but it gives us a lot more information during compilation about what is going on. So something doesn't just fail. It fails with a whole lot of information about the point that it failed, including what we can figure out might have been intended. Some people say it should just automatically do what it thinks you ought to do. And those people are wrong. But this is so important to our community, these error messages, that we have a category of bug called LTA. If an error message is less than awesome, it's not just, something no, it's a bug. And we need to make it awesome because we can, and it makes a big difference to the end users. Okay, and if we completely forget to put, I don't even remember what this does. If we completely forget to put anything in between, okay, it doesn't have a clue what you might have meant, but it knows that it's always wrong to have two terms in a row without an operator or anything in between them. You have to at least have a comma or something. And it goes further to say, in that spot in between, here are the categories of things that I was expecting. Which, if you're not at least a little familiar, those categories don't automatically jump out to tell you what's going wrong. But I think it's still better than the feedback you get from most languages. Oh, I have slides for that. Yeah. In the rush to get the sorting talk in good shape, I did not give as thorough a review to these slides from last year as I hoped to. But they're still really solid. Okay, Common string operations. You might recognize some of that from Perl. We have uppercase, lowercase. Used to be you'd have to do lowercase and then UC first in Perl. Now we just have one operation. It's title case, lowercase. Substring and cars. It used to be length in Perl. We don't have, if you try to use length in Raku, it'll tell you we don't have a length operator deliberately. I don't know what that is, but we don't have a length because it's ambiguous. There are places where you're using length to mean length of lists and such. And if you're using a string, the Unicode meaning of length is variable. You're talking about code point, how many code points there are, how many graphemes there are, how many bytes does it take up. So cars is essentially how many graphemes, how many visual characters or symbols are in that string. You can omit the parens when everything to the right's argument. Like that. There is bytes method. I may have a slide on that later. You might prefer the method forms depending on what your surrounding code looks like. For things like UC and LC, yeah, okay, you just move it at the end. But notice, you might have seen this in something like Ruby. That substring, that makes sense. Like you've got the thing that you're operating on, and you're doing a method call, and then saying what are the parameters of the substring that you want of that string. That makes sense to me. Doing things like quote, quote, dot join, and then giving it a list is backwards. With methods, we have sane objects that are running the methods. Even if you never use object-oriented design, even if you never have an object or class or anything in your code ever, you still may end up using the method call syntax substantially. There are just a lot of situations that have nothing to do with OO where the method call is a cleaner read because we can chain them and don't need parentheses. Okay. Since Unicode began, Perl has always had the premier Unicode support of any language. Raku improves on even that. Every string inside Raku is a Unicode string. If you need it to be something besides a Unicode string, we can encode, decode to IO streams to get it on disk, or in memory to get a blob that you can then manipulate. But if it's a string, it's in Unicode. If it's not in Unicode, you changed it to something else like a blob. The levels of Unicode are the grapheme, I said this earlier, graphemes, code points, bytes. So that's Brule as graphemes. That's the natural read of it. You would say there are 6 things there. And those are the code points for those 6 things. But there are ways to encode this where if the next to the last E, the E with the accent, or whatever it is over it, there's a way to say, here's an E and a combining character of that accent, in which case you got something different, but the same number of graphemes.
How does Raku, or does Raku normalize Unicode so you can actually compare sanely what you've read from someone else, like you see like character and you use the
Does Raku normalize so you can do sane comparisons? Yes, it does. I can't get all the way down deep into the levels because there are multiple levels of normalization. When I was paying attention to the spec before we even had implementation, they actually were speccing a level of normalization beyond what Unicode spec'd in order to achieve more of do what I mean. I don't know that was achieved because there's cost. But when you get down to that level, I think that we've got mechanisms to say what normalization level to force a string to be when you need to do that level of comparison. But I think for just like combining characters, it just goes ahead and combines them, which has the downside of you can't round trip, right? Which everybody says, no, that's not okay. That's not okay. You have to be able to round trip. Well, I hate to break it to you. If you're using Unicode, you already can't round trip. Doesn't matter the language. Did that answer your question? Okay, cool. I've got notes here that we have levels of a level in between string and buffer, which is just a bunch of bytes, called uni, which is a immutable bunch of Unicode code points, potentially known to be normalized in some way. I won't go into it because I don't even remember writing that slide. Okay, moving on. Okay. So whether it's not spec'd, the current compiler uses normalization levels or normalization form C. Good to know. Thank you. Okay, so recently we added real, true, and false to Perl. You might see it in the lightning talk that I gave last year about what's new in Perl 5.36. In Raku, we went further. It's a type. There's a type called bool. And that's true and false with capital first letters. And every type knows how to boolify itself. So if you use prefix question mark or prefix bang, then you can create a Boolean value out of anything. And just like we have like AND in Perl, but we also have ampersand, ampersand. And one's low precedence, one's high precedence. We have low precedence versions of the question mark and the bang that's so and not. So you can ask something, is it so? Is not. Is so. Is not. That's from Larry. That's how it's supposed to work. Is not. Is so. Now, see, it's funny. When Larry said it, I got a laugh from you when I told you Larry said it. So these are coercion operators. They move values between the broad types of Boolean, numeric, string, or anything else really, is coerced into Boolean. We also have a prefix operator for string, the tilde. We were using that to concatenate. If you just use it prefix, so tilde something, it makes that something be interpreted as a string, even if it was a number or something else. Okay, this is a little weird. In Perl, if you nummify a string that doesn't have a number in it, it's not valid. You get a warning unless you don't have warnings on, but you would never, ever, ever do that. In Raku, we have a delayed warning. Okay, we have it's a failure, which is a lazy exception. So it generates an exception but it doesn't throw the exception until you try to use the value, which is often immediately, so you can't tell the difference. But it is convenient sometimes to not have it throw until it tries to be used. So like here, and also very slightly different rules on what's a valid number. If you have 5 with a whole bunch of spaces on either side, no, just no. We have .trim if you want to take care of that. No, I said that wrong. That is right. .5 with just spaces around it is a valid number, but 5 with spaces and then a non-numeric string after, that's what it'll tell you won't allow. That's even smarter. I don't know why I thought it did it the other way. Questions about that?
There's a difference with Perl and automatic assumption that a number is, or that a string is more than 0.
Is that a change from Perl's assumption that a string is always a number 0? Well, it's a different interpretation of how to yell at you. Perl doesn't actually assume that it's 0. Perl tries to create a number, and if it fails, then all it can give you, if you've told it it has to be a number, is 0. That's the best it can do, and give you a warning if you have warnings turned on. So it's yelling at you a different way. If you diffuse the failure, and do it in numeric context, that will also be 0. I think. I haven't ever tried it. That answer your question? It's a subtle point I hadn't thought about. Oh yeah, I got diffused up there.
So using kind of like Perl's tape checking, where you get a value from the outside, it's dangerous, you test it, and then you're happy with it.
You're comparing it to taint checking. I kind of see the comparison there, but I wouldn't draw it. Because it's not really trying for anything security wise. We don't have taint mode in Raku. Oh, I see the failure. Well, the failure is all right. Now I really see the comparison. Okay, the failure though is not attached to the 0 value. The failure is the object that's returned. Yeah, that's the substantial difference. It's an extension to the exception model. To have a kind of exception that has a delayed explosion. Okay, so let's try this. What string values are true and false of those? And what are the types of these? And what do true and false nullify to? Got 1 hour and 15 minutes to go until the break. Okay. Anybody answering? False, true, and true. Okay. That's not like Perl. That's slightly different from Perl. Certainly, the empty string, in classes, they teach you to memorize what are the cases in Perl that are false. because we like so much to say if whatever. An empty container is false. An empty string is false. Numeric 0 is false. But in Perl, string 0 is false, which leads to very rare but very weird bugs that Tom Christensen likes to yell at us about. And in Raku, they just decided, okay, string 0 is a non-empty string. It's false. I mean, it's true. It's true. Yeah, it's false in Perl. It's true in Raku. And of course, the string false is true because it is not an empty string. If we didn't have the quotes, it would be false. But in the quotes, it's just 5 letters, a 5-letter string. Like any other 5-letter string, it's not empty, so it's true. And oh, like the painting, this is not the pipe. I wish I could just right now rattle off the French, but yes, this is not false. Okay, the types of those strings, if I try and numify things that are clearly nums, what do I get? The 42 and 1.5 and int, ret, and num. And did you know that you had to put parens around to do the dot what? You found out pretty quick, yes. There are a very few places where the precedence is slightly tricky. It's very slight. They did a really good job with the precedence tables, but you'll find like occasionally, like saying -3, you have to put parenthesis around the negative and 3 to do a method call on it. Otherwise, you're doing a negative of a 3 with the method call. I have a note to show you this. So that looks like line noise. But it is the Booleanification of the nullification of the string 0. And this, is that, do I need to go up some so people can see it? Let's see that. Oh, I can't. How am I going to do that? I don't know how to do that. No, won't let me do that. Okay. There we go. So what's that? Well, I didn't do anything to it at all. That can't be right. Pardon? Oh. Complex, yes. Yeah, I guess technically the only imaginary we have is I as a standalone constant, but everything using I is a complex. Raku is an operator-rich language. We say that sometimes, operator-rich language. So it's helpful to learn to recognize the 3 most common kinds of operators and think of them in the official term. So the exponent operations in green, that's an infix. We call that an infix operator because it's in between its operands. The plus and the tilde are also infix. But the blue plus is a prefix operator, numeric coercion. Raku knows that it can't be the infix version of plus because there is no term to its left. So it actually has to keep track of, and automatically does, it's really brilliant, of where it is in the stack of things that are to the left and to the right of operator to know whether you're talking about a prefix version or infix version or a postfix version, like we have $A++. That's a postfix self-increment. We'll see those later. The operands are all actually syntactic sugar around subroutine calls. But it's sugar we really want, because that's how you want to do math. You don't want to say AND open paren 2, 2 close paren when you're trying to do 2 plus 2. This is marked consider skipping, but it's too pretty. That URL takes you to Mark Lentzer's periodic table of the Perl 6 operators, which is just gorgeous. It's kind of out of date, but just work of art. You don't have to learn all that. And you actually probably already know a lot of it. Like you see up there, you see the sorting talk in the upper right corner, all those comparison operators for numeric comparison and for string comparison. Except LEG versus CMP, they're all the same as Perl. And the math ones are all the same as math. The numeric ones are all the same as math. Basic math ops in the upper left. Comparison. It's fun. On to variables. Because we are not Haskell, where variables do not vary. A scalar variable holds a single item. We'll be hand-wavy about what an item is for a moment. It has a $ sigil. That's the real term for the symbol that's in front of our variable names, is a sigil. So this is a $ sigil, which means it is a singular, a scalar. Larry conceives of it as the sigils are noun markers linguistically. It tells you that this thing that you're just reading through code, this thing is a noun. It's a thing. $ are singular nouns. We'll have a couple of kinds of plural nouns in just a minute. But this code won't run because variables have to be declared before they're used, just like Perl strict mode's always on. We declare it with my. Well, for local declarations, we declare it with my. So that'll work. The scalar is the basic model that they teach in school. It's like a box with a name written on it, and you put something in the box, and you can then see what was in the box by referring to it by name. We can change what's in the box. When the change is based on the old value, you can abbreviate. We talked about that in the sorting talk. Minus equals is not built in to Raku as minus equals. All the infix operators automatically self-generate a operator equals operator. So if you create a brand new fusion, whatever the fusion character is in Unicode, fusion operator, and it's infix, then you have also created a fusion equals operator. So now it's 37. We can also define and initialize at the same time. Notice that answer and age are declared the same, but they hold different types, right? Answer has an integer in it. Age has a string in it. You can put anything into a scalar unless you have declared it to have a type, and then it's restricted to that type. We declare by putting the type in between the my and the $sign, or the sigil. So, if I do this, what will happen? Is speed going to end up being 62 or 63? Want to guess before you try? Say again? So you get, it's a guess of a runtime error. Why would it error? Because I'm creating a rat and then trying to stuff it into something I've said can only have an int or a subtype. By the way, those types, you can have subtypes of those things in them. And rat is not a subtype of int. And you're exactly right. It will tell you you can't do that. And I think these are out of order slightly. So it's essentially the same thing. If you said my int age equals a rat or a num, it should yell at you. And if you want to try creating but not initializing a typed variable and asking .what, it's educational, but I'll tell you in a minute. And same thing if without a type. This may seem trivial, but it brings up an important point about how type restrictions work in Raku compared to how people expect them to work. So in the example that you just spoke on, you're right, we get a type check. And it gives us a great error message, exactly what was expected and what was delivered that was bad. The way I say it is, you can coerce, but Raku will enforce. Lots of languages, lots of programmers expect that because you said an int, then that's a storage category, like in C. And if you try and stuff the wrong thing in it, it's got to put something in there and it'll make it fit. However, Raku doesn't do that. You can do that. You can coerce anything, but Raku does not coerce for you. Raku enforces the restrictions that you set. So you say something has int in it, you know, as the reader of the program, that everything from that point on, it has an int in it. Also, the compiler knows it has int in it, and it can make optimizations based on that. It might not optimize, but it will always enforce the type. If you assign something that is a subclass of the declared type, as I was just talking about, it's technically is or does in OO syntax. The wanted type, that works too. So numeric is the general, it's a number. It could be a real, a rat, int, a complex. And you try and put an integer or a rat in it. Both of those are subtypes of numeric, or at least they both do, the numeric role. So it works. Okay, just for the record, there was a section here on the box model, how it really works behind the scenes. And Jonathan thought it was important enough to have in there, and I've had a couple of people tell me that they wished that it was in there, and I maintain it is not useful for beginners. It just confuses things, and 90% of the people listening to this, it'll never bite them. And I can't do justice for the other 10% at this point anyway. Do you need to know more than I can deliver right now about what's really going on behind the scenes with scalars? There's a scalar inside a scalar, but it's invisible to your point. Okay. So those were all singular scalar variables. An array is an ordered collection of scalars. And the easiest way to get an array is to declare an @ sign as a sigil on a variable. So $ was singular, @ is one of our two plural noun markers. When you assign to such a thing, it will parse the right-hand side of the assignment in list precedence, which means that you can assign without the parenthesis that we would need in Perl and most languages. So notice no parens there. And in college, they taught us to think of like a line of variable boxes. Box 0, box 1, box 2. But with just one label for all the boxes, like animals, animal 0, animal 1, animal 2. In Raku, it's more helpful to think you get to it positionally. Still one name, but it doesn't matter how they're arranged. If you ask for number 0, you'll get number 0. If you ask for number 1, you'll get number 1. If you ask for the one after number 0, it knows it's positional. You're getting to it by the position. Arrays are mutable and dynamic. So you can change the value of any of those elements. After we put Peru in the second slot, you can go and change Peru. And the whole array is not fixed in size. If I then, let's see, 0, 1, 2, 3, if I put something in slot 4, then it just countries gets bigger. Can grow on demand, shrink on demand, can be used as a queue or a stack. I have a note here, frozen or immutable. Those are lists. That's something different. But arrays are of type array, right? I ask what? It says it's an array. And they know the number of elements. We can ask, how many elements? There are 4. Have a seat. Okay. We use the square brackets as an array indexer to access part of an array. If you don't do that, you're talking about the whole array. If you use the square brackets, you're talking about part of the array. In this case, just one element at a time. Notice that that star in Perl, we can just say have negative numbers, and it automatically indexes back. Raku for, okay, I'll read this. Raku, you have to have a star before the sign. And my note here says, parenthetically, why? My current answer goes on a long tangent involving the whatever star and probably shaped arrays. I will write a better answer for next year. Update 2023. I did not write a better answer. Assigning to an element that does not yet exist will extend the array, and not just by 1. If I then assign to element 100, then I've got a 101 element array and a whole lot of undefined values in between. You can refer to multiple elements at once. And the last time I gave this talk, we were de-emphasizing the Perl stuff. This is a Perl and Raku conference. I'll point out these partial references keep the @ sign. I may have a slide on this later, but in Perl, sigils are variant. They change depending on how you're using the variable. In Raku, sigils are invariant. They never change. If you were talking about the country's array, you will always use the at sign, whether you're getting part of it or all of it. Skip. Okay, we've been initializing countries like this. Those are all single words. So we can use the word quoting syntax to make it easier on the eyes. Okay, though items are divided by white space, doesn't have to be single, it could be tabs or 3 spaces, whatever. Just like Perl's QW, quote words, but we don't have to say QW, you just use angle brackets. Now, why doesn't the compiler see the angle bracket, that first one, as a numeric less than operator? Isn't that ambiguous? Hmm? I don't know what you're saying. Oh, that's an interesting theory. I had not thought about that. The assertion is that maybe it recognizes the first angle bracket should be part of a pair by seeing the second angle bracket. That's a very interesting idea. It's not correct in this case. It's a good guess. What we were talking about earlier of, again, please? Oh, is it about the array assignment? That's also an interesting theory. And I didn't hear every word of that because you're talking too soft for my ears, but I understood your gist. Also good, but no. And I can't remember. I'm conflating now what we've already covered in this class versus what I talked about in the sorted class earlier. Yes. It's about the same as the plus sign. It knows, no. Okay. There are term positions, and I get my terminology wrong in the syntax, but there are term positions, there are operator positions. The angle bracket is happening in a term position, and so it would have to have not in a term. Anyway, it would have to have a term in front of it for it to be less than. We don't have a prefix. There we go. We don't have a prefix left angle bracket. Therefore, if it doesn't have anything to the left of it, that's a term for the less than to operate on. It must be the angle bracket signifying quote words. Yeah, that's one I really should have had notes on. There are several places in our syntax where things are reused because they'll be clear to the compiler and clear to the reader as long as they've had a beginner class of what's meant. Okay, this happens in Perl. We want to spell out United Kingdom and say instead of saying UK, and that breaks because now we've got the word unitum and the word kingdom because the way quote words works is it divides on white space. So kingdom is a separate country. That's wrong. What do we have to do to make this work? Well, just like I talked about, you've got single quotes and then you've got superpowers for double quotes. We talked about how single angle brackets work and there's superpowers for doubled angle brackets. So it's a double form of word quoting with more complexity to learn, but more power, just like single quote strings, double quoted strings, more complexity, but more power. Inside our double angle brackets, we can single quote things to make them stick together. So United Kingdom is now, again, one thing. Could I use single angle brackets inside the double angle brackets? I don't know. Will you try it and let us know? For those of you who haven't met him, Joseph Brenner is our fearless leader of the Raku study group that meets for 3 to 4 hours every other week. It's if you you're interested in continuing your Raku education and you can take the time, it's a good bunch of people. We have a good time. There's a Unicode spelling of those double angle brackets. I haven't needed it much, but when I did, it felt perfect. Okay, still working with arrays. You can push and pop the end of the array, just like in Perl. We could have used push and pop as functions instead of method calls. By the way, just about everything that was a function, like in Perl doc, Perl func, or Perl doc -f push, or any other function you want to put in there, it's been brought into Raku as both the function form and a method form. Stuff that we added tends to be just method form, but not always. Like cars is both function and method. If you want to work on the front of an array, you use unshift and shift. If you use push and shift together, and that's all you use, you get queue semantics. If you use push and pop together and only those, you get stack semantics. We also have, I don't have a slide, but we have dot head, dot tail, and dot skip, which you can achieve the same thing using just regular references, but they work with, well, head and skip work with infinite lists, with lazy lists, and so it's very useful for that. And sometimes it's just clearer to speak of things as, skip 3 and then take the next 4 instead of saying, whatever the angle bracket syntax for that is. I don't want to do the math wrong in my head in my sleepy state. Oh, I already went through that. So that's the same in Perl. Other languages may have dedicated queues and stacks. And sometimes it's useful to enforce those semantics. But our arrays are just, in Perl and Raku, are just so generally flexible that we just use them this way to mean this thing. Oh, I've got illustrations you probably don't need. Okay, I only do the first two. What happens if you assign to slot 0 and 3 in an array? How many elements do you have? And what's in slot 1 and 2? I think I already spoke of that, but if someone wants to try it, that's cool. And if you assign one array to another, do you get a fresh set of scalars? I don't know what I meant by that. I'm sorry, I don't know what Jonathan meant by that. Okay, I'm going to go on, and if someone wants to speak to that later, feel free. So moving from arrays, where everything's ordered, indexed by position in the order, we're going to go to hashes, where nothing is ordered, and indexing is by string. Quick story. In college, I saw a new library book on the language Snowball. Not COBOL, Snowball. The first page said that Snowball has only one data structure, a whole language based on this new thing called a hash, where you can, at high speed, look up values by their string key. I said, who would want that? And I put the book down. I was a great computer scientist. Follies of youth. Easiest way to get a hash is to make a hash variable. We have a new sigil, %sign. So $ is singular, and @ and %sign are both plural, just different kinds of plural for how they're organized. We can initialize it with a flat list We're talking about capitals. That's going to say key is UK, value is London, and then key of Peru has the value of Lima. Or with a list of key value pairs. We haven't talked about pairs, have we? This deceptively looks just like Perl syntax, where the equals greater than, we call it the fat comma. It works in Perl just like a comma, except it automatically quotes whatever's on the left. That is not how it works in Raku, but it's so similar that you'll often trick yourself and think that it is, because it's so well designed it works. So, that in green is no longer a fat comma, it's a pair constructor. You automatically quotes the thing on the left, takes the thing on the right, and makes a pair object out of it, sort of like a two-element array, except instead of talking about the two elements as 0 and 1, you talk about them as the key and the value. Even if they're not associated with a hash, they can just be a freestanding object. You would get at ABC of that with the dot key method and the XYZ with the dot value method. So, hoisted into a pair, it's a pair type. That is a type. And I've overrun my slides again, talked when I should have been showing the example. Like that. Questions about that part? It's subtle. Good question. Is this the only place that bear words are allowed in Raku? Those aren't bear words because they're being automatically quoted by the operator. Just like inside the angle brackets, those weren't bear words. Those were word quoted. Yeah? Yeah, okay. He gets it. But it's a good question. Okay, so pairs show up a lot when we're using hashes. Back to where we were with ABC and all. So, go back to where we were with the capitals. That bottom initialization I'll reformat it in a way I only use for presentation slides, like that. Now, how do we access part of a hash? We were using square brackets on a array. We use curly braces for a hash. Percent sign stays. We got invariant sigils. And I don't know if you've ever used it in Perl. There's this trick where you can get at multiple things in a hash by using an @ sign, which just sounds crazy, but you're using it in kind of list context, so it's @ sign. It's still here, we're invariant. It's always the percent sign. If you've got that hash declared with the percent sign, it's always a percent sign. And you see, I can't just say UK. When I was first teaching this stuff, people would complain about that because people love to be able to say UK without quoting it. But we can't do that anymore because that would be bear words and we can't have bear words. So you have to use the quotes. There's no way around it. You have to use those quotes. But look, you can just have multiple things and you refer to it in multiple keys, you get multiple values. That's got to be worth the change, right? But mandatory, man, it annoyed me. And it was annoying everybody, which is why they dovetailed it with the word quoting syntax. And if you use angle brackets instead of curly braces, then it word quotes what's inside the angle brackets and uses that as the keys. So now we're back in paradise. Saves typing, looks neater, and still follows the rules of we don't have bare words.
Can you say more about the distinction between a bare word and a word?
There are places in Perl with ancient things like formats and hash keys where it's just understood that if you've got something that really ought to be a string, but you don't make it a string, it'll be considered a string. And those are bare words.
But what would be different about that that allow you would put examples from that?
Oh, you mean if it just automatically interpreted whatever was in there as, well, my knee-jerk response to why don't we just make the same thing work without the angle brackets? Why don't we just make it work with curly braces? Is bare words are, from what I've heard of the core folks, a real problem in the syntax specifications of Perl. And it was deliberate to get rid of them. So this is a way around that. I don't think I could speak to it past that. There's something that it would that this design catches that other things don't, that I'm not thinking about. Probably. Joe's impression. Yes. So that's a good point. Curly braces in lots of other places imply code evaluation. So what's ever inside that ought to be like code-ish. You can put in a function call or whatever and use that as the lookup. I think conceptually that's clean, but I don't know that that's the answer of why. Yeah, it's plausible. Yeah. But if you are putting in a function call or a variable, then you would be using the curly braces. That's the general case. Okay. I don't know if you're as interested in this minutia as I am. I think it's because I did a Perl Monks talk about it, a Perl Monks post. You could ask in Perl, does this key exist in a hash? It's a function. It's in Perl func. We don't have exists because exists can't actually work in Perl. I worked in Perl for years and years and years and never realized this. If you want to go and implement push or any number of other things that Perl provides you in Perl, you want to do it yourself, you can do that. You cannot implement exists as a subroutine call that you've created in Perl. Because as soon as you say, does this hash have this key in it with the syntax of it's in curly braces, you have looked it up. Perl is cheating to define exists and delete the way it does. And they decided they did not want to be cheating in that way anymore in Raku. So, being linguists, they created adverbs. So instead of using exists the way we did it in Perl as just a function, or having to resort to passing a hash completely separate from passing a key, you do the same indexing that you normally do. You just add :exists. Colon is the adverb marker. :exists says, do this, but only tell me, does it exist or not? And you can do it for multiple things. And it makes more sense. Adverbs in English modify the verb. The verb is the access. We're modifying how we access. We're not accessing to get the value. We're accessing to find out the key's presence. There are also other adverbs for things like if you're doing a substitution and it's going to be global, instead of having a G at the end of the last slash, you use :G. It's modifying the substitution. And if you're doing a grep and you say :K, then you get the keys of the things that you were grepping instead of the values. How are we on time? Is the break now 3 minutes or at the half hour? When you ask a dictionary of the hash, that's interesting. Can you walk me through the exact?
Sure. So like my percent.
Okay. Say it again. Okay. Oh, just that. Oh, okay. I thought for a moment you were telling me, no, exist does not return a Boolean. It returns. You're just you. Yes. Okay. So I don't know if I have a slide about this earlier, so I'll tell you now. You've stumbled upon an interesting bit. In Perl, we have lots and lots of defined values and one undefined value called undef. For lots of reasons, we don't want that in Raku. But we do want undefined values in Raku. They're incredibly useful. So if you have an undefined int and you ask if I do that. I guess nobody, this was one of the things that was try me that was skipped over. So that it's got int in parentheses. We have multiple types of undef. We have a type of undef for every type that we have and a few more. So whenever you see int in parentheses like that, it's saying that is an undefined integer value. And when there is no type, then it's of type any, because that is our almost root value of the type tree. There is one above it called mu, mu, from the old, from the eternal Zen.
I agree with you. This is confusing, by the way. If you assign nil to the scale, and then say the variable, it says it why did you say nil? Why did it change?
Okay, and Joe's bringing up this is confusing to more than one person, but going into using nil to clear a value is something beyond the scope of this. It's technically a different problem, a different point of confusion, but I'll agree that it is somewhat confusing. In this case, it was just surprising. You hadn't been introduced to the any type. When you don't put a type on a declaration, it's any. And I'll note that if you do this with delete, it returns the deleted value as it's removing it from the hash, which is also how Perl does it. It's useful sometimes. we can ask a hash to give us only the keys, only the values, just like Perl. But we can also ask for pair objects. And so the result of that pairs line is 2 pair objects. If we ask for it as .kv, then it gives us a undivided string, key value, key value, key value, key value, no differentiation, which you might think you would never want instead of pairs, but actually when you combine it with for loops that we can easily make automatically take 2 values at a time, it's even smoother than working with pairs. Oh, yes.
Someone asking you to anticipate it by saying, what if you've got spaces in your key?
I don't think I'm going to be speaking of anything clever about having spaces in your key, so let's explore that for a moment. What about having spaces in your key?
Supposing it was, for example, the United Kingdom and the capital.
Okay. All right. Well, yes. So the 2 aspects of it are how you say it and how it's taken. Oh, that's badly worded. Let me try that again. Yes, you're right. Thank you. Good catch. I'll fix that in a moment. Oh. How annoying. Let me just try it like this. I used a double quote and a single quote, but it is still in this double quote mode. So better? Yes, good. Oh, except I'm at 42. This is obviously not the answer. Anyway, this gives me an opportunity to say there's a .raku method. Anybody use data dumper in Perl? We built it in. Tell me the Raku that you would need to have in order to create this data structure. It's very convenient when you're investigating stuff in your explorations. There's also a shortcut to say DD. The .raku is actually returning a string that is getting said. DD automatically does essentially the same thing and outputs it. So you see, there's no problem with having spaces in a key from the hash's perspective. Okay, it's just a string. It's indexed on string. It could be a Unicode key. It could be any kind of string. I guess they're all Unicode key. You know what I mean. They have Unicode characters in it. The problem comes with how you communicate that key string. And I can do it like that. I cannot do it like this because that will be 2 different keys. I wonder if I can do this. Yes, that works. So same nice way that the rules carry over. I don't know how many spaces I put in there. That looks right. No. There. All right, wait. Start over.
Oh, sorry. If you're, say, you're creating and using parent instructions, like you did in your other example, but you were relying on quoting the left-hand side. But if you wanted the space in there, you couldn't rely on that. You could use something else.
Right.
Where you quote.
Yes.
It is interesting that you don't end up with quotes inside the key. They understand that, oh, he's quoting this, therefore I will quote.
Let me, rather than repeat that verbatim, let me just illustrate. It is of interest that if I'm creating a pair, and I want a double quote, I want spaces in the key. No? What's wrong there? Oh, yeah, thank you. Okay. That it does not take the quotes as part of the key. It is smart enough to know that, yes. And that, I want to say that it's actually about the word quoting mechanism in general, but I don't know. It is nice. It would be inconvenient if it didn't work that way. So, yes. But well, yes. Yes. Me either. Yeah, it's had not occurred to us. Okay, so that was a branch for a moment, useful. Alan, did that completely address what your question is, or is there some other aspect needs exploring? Okay. If another clarifying question comes to you, or if it comes clear, please ask. And I don't even remember what's here. Let's talk this through. Anybody can run it if they want to. But are pairs first class objects in Raku? Well, yes, they are. We got a constructor and everything. And if you do all the examples we've been doing and put UK into A, what will that first one do if the $A is in curly braces, and what will happen if you put it in angle brackets? Assigning, I'll talk about assigning hash in a moment. So anyone want to venture a guess on that second one? I mean, obviously, in the curly braces, it'll do the right thing, right? What happens if it's in angle brackets? Because what are we asking for? We're asking, what is the key, the 2-character key, $, and A? And no warning, interestingly. I don't know if it ought to. Okay. If you assign a hash to another, you get a copy of it. If you assign a hash to an array, in Perl, it flattens the hash. You get key value, key value, key value, and that's really painful, especially when you're sorting. I didn't get into it in the sorting talk, but that's completely useless if you're sorting. You have to go through hoops you shouldn't have to sort, because the keys don't associate in any way with the values. They're just next to each other. If you unwind, if you list out a hash, including by assigning it to an array, you get a list of pairs. They aren't necessarily in any particular order, but it will be, if you've got 5 keys in your hash, you will get 5 pairs in your array. And that is so much more useful. If you assign an array to a hash, it will try to do the old thing that Perl does of pairing up key value, key value, key value by taking every other one, which is useful sometimes, unless it detects that the first thing in that list that you're giving it is a pair object. And then it'll expect them all to be pair objects. So it does the right thing in every circumstance. And if you ever need it to do that in any other context, I couldn't believe they did this, but they implemented a method. The dot pair up method does what I just described, including the, but if it's a pair object in the first one, then do it differently. And, and so it pairs them up. It doesn't put it into a hash. It just pairs them up into pair objects. I actually used that in a weekly challenge the other day. If I'm remembering right. I used it somewhere the other day. And what happens if you use keys or values, KV or pairs on an array? Does it explode? Does the world end? Anybody know?
If I remember correctly,
Keys is the indexes, right? You got it reversed. Pairs is the pairs. You're right. Keys is just the key objects. Values is the indexes. Keys is the indexes of a array. Values is just like you didn't say values. But KV is that flat thing that is generally useless, but occasionally useful. And yes, the way Perl unwinds it. And pairs is the pair objects. And just because so many people missed it for so long, I have to say, in the middle of a Raku talk, if you're working in Perl, keys on an array works. You don't have to say 0 to @array -1. You don't have to say 0 to $% name of the array. You can just say keys array since like 512 or earlier. For the longest time, they didn't document it. It was left out of the Perl Delta, but it's been in there for like forever. So every time I see Perl code that does it any other way, I'm like, it's cleaner this way.
You mentioned when it sees a key value that's the first thing in the list when it's building a hash, it assumes the rest is going to be key values.
So it's going to be pair objects, specifically, not key value, but pair objects, if it sees the first one.
It's just made me think, is there a way that you can tell Raku that this is a list of ints or this is a list of strings, so I know it's a proper array?
Oh, can we type an array? It's actually a completely independent thing to whether we're assigning to a hash or something.
Yeah,
Yes. Okay. Well, yes, we do have typed arrays, and I'm not ready to speak on it. It's not really a beginner topic, and there are edges to it that I have not found the best way to teach or the best way to use. Okay. The type restrictions on scalars I use all the time. I don't necessarily put every single variable with a type, but like on parameters for a subroutine, that's a great edge to put it. It catches a lot of errors. It's just great. But typed arrays, very, very briefly, if you want it to enforce the way most people think about it, then Raku would have to check on every subroutine call, every assignment, that the whole array obeys those rules. And that's ridiculous, performance-wise. So instead, they said, if you say, this parameter will only take an array of ints, then whatever you pass it has to have been declared an array of ints. If it's an array that happens to have ints in it, that's not good enough. And I found that I have not found how to make that useful, to make it not grating. So I just don't right now. I'll let them iron it out some more and then come back to me and tell me how I ought to be using it, and maybe we'll be happy. Is that enough explanation? I know it's not as deep as I want to give. Okay, 12 more minutes. Can we make it? Sure, speed of light. We have real constants now, instead of having to say use constant with all its restrictions in Perl. We can have constant scalars, we have constant arrays, and you can declare them anywhere that you would have said you can say constant. You can even leave off the sigils if you want to. But then you have to use it without the sigil, and you can't interpolate it in a double-quoted string without using curly braces, and I find it better to leave them on. But sometimes you're doing something like, if you want it to be C in a scientific equation, because they say C is the speed of light, you don't want it $C, because that's not what the equation says. You want C. So you can leave out the sigil. We have some built-in constants. In Perl, you have to define E and pi. Actually, Dominus says there's an easier way to do pi, but this is the one I memorized, so I always use it still. And everybody know tau instead of pi? There's a website about how tau is what we should all be using. It's just 2 pi, but tau is the honest cornerstone of the universe. Pi is just, it's just half of tau. So we have those in Raku built in both their ASCII version and their Unicode symbols. Always fun to use. So we've been using sigils. Why do we have sigils? Well, I told you, noun markers, but also useful because of interpolation. In single quoted strings, nothing interpolates. If you put a $sign in a single quoted string, it's just a $sign. In double quoted strings, they interpolate, just like Perl. If it sees a $sign and a word next to it, it expects that is the name of a variable. If it's not the name of a variable, it will yell at you. If it is the name of a variable, it substitutes its value. That's interpolation. You can interpolate arrays and hashes, but we had problems in Perl, especially with the @ signs. If you put somebody's email address in a double-quoted string, then it has an @ sign followed by what looks like an array variable. So we wanted to be able to not have to worry about that. So we have a Zen slice. If you want to interpolate winners, you need to if you want to interpolate one or multiple elements, then you just use square brackets and the elements you want. If you use empty square brackets, it's a Zen slice. And that's what triggers the interpolation. And by the way, it interpolates with spaces between them. It doesn't run everything together the way Perl would. Same rules for hashes. You can interpolate method calls. If it ends in dot and something and parens, for the same reasons, you've got to end in parens, then it'll interpolate that. And we have to have that rule because of file extensions. Otherwise, interpolating that final one would try and call the txt method. In double-quoted strings, you can embed code using curlies. When I was first teaching that, I got a lot of pushback from Perl people that's awful. You don't do math in strings. You don't. Well, that's true. Why would we add such an evil thing? Perl doesn't do that, right? That's Perl. Anybody have any of that in their production code? When you found it, did you murder whoever wrote it? We've had this already. This isn't new. We just gave it cleaner syntax. It's always been in there. We also never told anybody it was in there. You have seen it used in real code. I am so sorry, then. Yeah. Well, sometimes it's what you need to do, and curly braces, curly braces look like code, so you put them in a double-quoted string, you got code that'll run in your string. We got rid of we cleaned up a lot of stuff that was buggy in Perl, in the way it gets used in real life. This is one that we didn't get. So
I take it in that example, the 8 that you got back is essentially the value of the first element of the array.
no, it was the number 5 plus 8. I mean, 5 plus 3 is 8. It's I see what you're saying.
You did the calculation and stuck that value.
It did not actually put it into an array. What happened is, well, yes, it did, but it wasn't the 8th element. We started out with a dereference. So what is inside this @ and curly braces is to be interpreted as an array and taken out of the array. Okay, so give me the contents of this array. Then inside that, we use the anonymous array constructor to create the array that has to be dereferenced. Inside that, whatever the expression is becomes the first element and the only element, and then that gets dereferenced. It's just evil. But you were close. Okay, so what I haven't gone into is, I said our sigils are invariant, and they are. If you declared something as as %H, then it's always %H, however you're using it. But scalars can hold anything, including arrays and hashes. And if you treat a scalar, you try and dereference it with a curly brace lookup or a square bracket lookup, it will assume that you mean, this scalar has a hash or has a array inside of it, and just do the right thing. So what this looks like is that we must have a scalar variable named name that contains a hash that we want to do the quote words lookup of the string /b. And if we had that kind of craziness in Perl, there is a way to avoid it. I'm just going to freehand this. If I was going to print this string or whatever in Perl, whoops, this is E, and my variable is f, that's a problem because it's going to try to look for FGH. And so this is another way of writing $F that is just an alternative way you hardly ever use in Perl. That you put curly braces around the F, and that tells the $sign what it's referring to. It's not even a dereference. It's just another way to say $F that can't be confused with something that's right next to it. So in Raku, we just moved it. So that would be the answer. You just put curly braces around the name part, and it will insulate it from being interpolated. Is that right? Yeah, I'm going to try that to be sure, but that's supposed to be the answer. 2 minutes. I think we're going to make it. We made it. Okay, so when we come back, by the way, it's perfectly fine if you don't come back, but if you'll tell me now that you're not coming back, I won't expect you to come back. Anybody? Just, that was a good end of it, or you got a really good other talk you want to. By the way, if you want to go to another talk and then come back in the middle of the next session, that's cool too. But I don't want you to miss your break, so you got an extra minute.